Alright class, so I want to give you a quick little demo of kind of what we're looking for in our video projects if you decide to go with option number 1 for the project. So first things first, here we have YouTube pulled up with the clip that we want to watch from that Fast and Furious 7 scene where the car is going to jump between one building to another. Just a note about recording. All you have to do is at the top right of your iPad screen, pull down. What we want is to see that little circle that's blinking there. That's going to be the one that signifies screen recording to us. If we hold down on it, it pops up this window. We want to make sure that at the bottom there, our microphone is turned on. That will allow your voice to be picked up over the video. And that way, when you kind of can go in attain Notability and describe the thought process you have of how you're going to work through the problem, that voice will be recorded into your video. So to start, all we're going to do is begin our project by playing our YouTube clip.
You realize what this is? Like in hypersport? $3.4 million, 0 to 60 in less than 3 seconds. There's 7 of these things in the world, and this guy keeps it locked up in a vault.
Nothing sadder than locking a beast in a cage.
And now I really want to punch him in the face.
Okay. Let's get to work.
Guys, I can't hold it. I'm losing the final gate. You gotta get out of there.
Tear off the dash. Go through it. Time to unleash the beast.
Stay with me. I got you.
Let's get the hell out of here.
Done. Cars don't fly. Cars don't fly. Oh, shit.
Alright class, so we're going to pause the video there. Again, in this analysis, we're going to be looking at just that first jump from one tower to the next. So when I think about what I'm going to want to do in Notability is I'm going to want to first kind of sketch what we have here. So, all right, we're going to have 2 towers here. We'll have this be tower 1. This next one will be tower number 2. Now, in the scene, what they had was they were jumping between 2 out of the 5 Etihad towers that are in Abu Dhabi. So what I'm going to do is just to get a little bit better perception of the height of each of these buildings, I'm going to do just a quick Google search, look at what we have for our Etihad towers here. And what we can do is we can find that out of the 5 of them, they're going to range in height from 218 meters to 305 meters. So for our sake, what we'll do is we'll look at the kind of these first 2 towers. We'll say we're going to jump from tower 1 into tower 2. One thing we'll also notice here is if we look at the floor numbers, what this equates to is roughly 4 meters per floor. So what I can do is say we'll start at 277 meters will be our first tower, 305 will be our second tower. So we have a height here, and we said that was 277. Our second tower is going to have a height of 305 meters. Now, one thing, if we think back to the video, we didn't actually drive off the roof, right? Instead, we drove off of some kind of upstairs floor here. So if we think out of the total of 69 floors we have in Tower 1, let's say, it looked like to me it was more or less closer to the top. So let's say we're going to start at floor 52. Again, that's a little bit of an estimation I'm making. I'm not going to be 100% accurate there, but for our sake, to help us analyze the problem, we're going to say we're at floor 52. And if we think that each of our floors is going to be 4 meters tall, if we do 52 times 4, that is going to give us a value of 208. So we're going to say that we're going to start here at a height of 208 meters. Now we know as we are driving and as we break through this glass window here, we're going to have some initial velocity that will then allow us to kind of follow along our parabolic motion. And our job is to figure out here, is our motion going to be something where, we are going to drop and end up hitting the ground? Or is this scene accurate and we're actually going to be able to go far enough that at some point we're going to crash into the building here? Now there are a couple more kind of approximations we're going to be able to make to help us solve this problem. So first thing is, I'm just going to estimate that the distance between these two buildings, we'll say it's going to be 40 meters. Again, I'm making up this value. When we think about 40 meters, that's just under 44 yards. Seems like it could be a realistic kind of distance we have between two skyscrapers that are next to each other. Again, I don't know what this value is for certain, but I'm going to go and use this approximation of 40 meters. The last thing we're going to want to do is figure out the speed at which our car is traveling. So what we're dealing here with is the Lykan Hypersport. So what I did was I looked up information about this car here. And at the very bottom of our page, we can find just some specifications that they have here. So if I look at this car, they give us a couple of values we can use. They tell us that we can go from 0 to 62 miles per hour in 2.9 seconds. They tell us we go 0 to 125 miles per hour in 9.6 seconds. Our maximum speed is going to be 245 miles per hour. So thinking about this, I would say that the car was speeding up somewhere between 3 seconds and 9 seconds. So we're going to fall somewhere in between here. I'm going to say maybe it was about, they were driving inside the tower before they broke through at about probably maybe 5 or so seconds. However, when we think about the impact that the car has as it hits the glass and kind of comes out, that's going to dramatically decrease its speed. So I'm just going to go ahead and make this estimation that, let's say we're leaving the one tower with a velocity of 60 miles per hour. Now, because I want to make sure that our information is in terms of our SI units of meters per second, I'm going to do a quick conversion of 60 miles per hour and see what that is in terms of meters per second. So if we leave at 60 miles per hour, and then you're going to be traveling at 26.8 meters per second. So going back to our diagram, we can kind of finish that. We're going to say we're going to have a velocity that's equal to that 26.8 meters per second. Again, we got that from converting 60 miles per hour into meters per second. So my job here to figure out whether or not this is going to be realistic or not is I'm going to try to find our final height after we've traveled that distance of 40 meters in the x direction. So I want to find y after we travel 40 meters in the x direction. Now to do this, I'm going to want to set up an XY chart here. So just like what we've been doing in class here, we have our initial position, final position, initial velocity, final velocity, acceleration, and time. And what we're going to say is that our initial position in the x direction is 0 meters, and eventually we're going to try to figure out what our height is after we've traveled that 40 meters in the x direction. So we're going to say our final position in the x is going to be 40 meters. When we look at the y direction, we're going to use this 208 meters, or estimation of being at floor number 52. So we're going to start off with initial height of 208 meters. My height that I'm trying to figure out, which will allow us to figure out if we crash into the second building or if we fall too short, that's going to be unknown. That's what we're trying to solve for. Now, we're going to try to approximate the situation by thinking about this as only having a horizontal initial velocity of 26.8 meters per second. So what that's going to tell us is that our initial velocity in the x is 26.8 meters per second, whereas we're going to have 0 initial velocity in the y direction, as we're only moving horizontally as at first. Again, for these type of questions, we can always say our acceleration in the x direction is 0 meters per second squared. Then our y is going to be negative 9.8 meters per second squared. Again, our time is going to be unknown, and we're not going to know what our final velocities are. So in terms of kind of the two parts we want of the diagram and the chart, we want to hear you as you kind of walk your way yourself through that process. I want to hear the estimation that you make. Again, if you would like to do research like what I did on the Etihad Towers and the Lykan Hypersport car, right, you can kind of do a little bit of research, show us where you got these estimations from. And then from there, we want to hear you kind of walk your way through setting up our chart here. Final thing we're going to want in your videos is to you explain kind of why you chose the equations you did and how you're able to work through that math to solve for this variable that you're trying to find. So for my case, I'm going to be trying to find our final height. So to start, if I take a look at what we have in this XY table here, I know in the y direction, initial height, initial velocity, acceleration. Right now, that's not going to be enough to help me figure out what our final height is. So I'm going to need to know some information about time before I can do that. So one thing that's going to help us figure out time is if instead I look and focus in on our x direction. So I'm going to start by looking at the x direction here. And I want to figure out the time it's going to take us to travel 40 meters. So I'm going to make use of our initial position, our final position, our initial velocity, our acceleration. I want to figure out time. The equation that's going to let me do that is going to be our third kinematic equation of x final is equal to x initial plus initial velocity in the x direction times t plus 1/2 times acceleration in the x times t squared. So plugging in the values I know, we're going to end up with final position of 40 meters. We start initial position at 0 meters. Our velocity in the x direction is going to be 26.8 originally. We're trying to solve for time here. Then we're going to have 1/2 times our acceleration is 0 times t squared. So when we work through math to simplify this, we're going to get 40 is going to be equal to 26.8 times t. Again, that 1/2 times 0 times t squared is just going to be 0. So let's figure out the amount of time we're in the air for. We do 26.8. That's going to be divided from our 40. So 40 divided by 26.8. This is going to give us a time that is equal to 1.4925 seconds. So now that I know this time, I can go back and figure out what our height is going to be after this 1.4925 seconds. So looking at the variables we know in the y direction, I don't know what my final velocity is, so that means I can't use equation 1 or equation 2. So that means I'm going to have to use our third kinematic equation in the y direction. So we're going to have our final position. It's going to be equal to our initial height plus our initial velocity in the y direction times time, plus 1/2 times our acceleration in the y direction times time squared. So plugging the values, we have an initial height of our 208 meters. We're going to add that to our initial velocity in the y direction of 0 times by our time of 1.4925. Can be added to 1/2 times negative 9.8 times our 1.4925 squared. So we're going to have y is going to be equal to 208 plus 0 plus a negative 4.9 times, and if we do this 1.4925, if we square that value, we're going to get 2.2277. If we multiply that by our negative 4.9 here, we're going to have 208 minus 10.9156. So finally, we're going to end up at a height of 197.08. So again, shockingly enough, what we find here is that based upon our estimation of one floor being equal to 4 meters tall, we're really only dropping our height by about 2.5 stories here. So again, we've simplified this a lot. We've ignored air resistance, but this situation in the video actually could be possible if we were able to leave our building 1 at a speed of about 60 miles per hour. We would in fact make it to the second building. We would only drop about 2.5 stories down.